Hi, everyone, and welcome. My name is Kaylee Wong, and I want to thank you for joining today's live stream event. Today, we're really excited to walk you through the new features and functions released with Vault 1.9. This includes an improved Vault Agent Persistent Cache, key management secrets engine for GCP, and a new tech preview feature for Vault to act as an OpenID Connect identity provider. Joining me today is Justin Weissig, Senior Product Marketing Manager. During our session, we'll jump into our latest product features and then follow that up with Q&A. Just an FYI, this webinar is being recorded and the recording will be made available after post-processing, which usually takes about 2 business days. And then lastly, please type your questions in the Q&A box and we'll answer them during our Q&A section at the end of the presentation. With that, I'll turn it over to Justin.
Awesome. Thanks, Kaylee. All right. Let me just switch sides here. So before we dive in, I just wanted to post a few reference links. This is to the blog, the release announcement that went out on November 17th. So if you're watching this on YouTube in the future or something like that, so you know the date. Also, when we upload this to YouTube, we'll post all the links in the the little description underneath the video, just so you have everything. But for now, I'll paste them into chat. Also, as Kaylee mentioned, at the end of the talk here, well, I'm just going to go through the features, both open source and enterprise. We'll chat about that for about a half an hour, and then we'll open it up to questions and answers. So if you have any questions as we're going through it, definitely use the QA box, and we'll make sure to get them answered. All right, so let's dive in. So what I normally like to do is, I imagine if you're on the webinar here, you're probably pretty familiar with HashiCorp and Vault. However, I just want to maybe spend a couple minutes and chat about HashiCorp and Vault, just so everyone's on the same page. So HashiCorp is a company that focuses on infrastructure automation tooling. So we have a variety of products that help you provision, secure, connect, and run your applications. So if you're thinking about provisioning infrastructure, you're maybe using Terraform. If you're thinking about, hey, I have a service mesh and I need some sort of a service catalog, you're probably looking at Consul. Vault is in the security domain, and we're going to focus our discussion on that today, as well as there's a variety of other tools. So since we're specifically talking about Vault, what is Vault? So Vault is a centralized service that will sit on your network, and its primary function is around secrets management, but it has a bunch of capabilities beyond secrets management, and we'll sort of dive into that. So we have secrets management. We have a lot of capabilities around dynamic secrets. So say, for example, I'm a database administrator, and I want to rotate the root password on a database, monthly or something like that, maybe for compliance reasons. Or maybe I'm a DevOps operations person, and I need to access my AWS environment. Vault has the capability of generating, short-lived dynamic credentials that you can log into things. We also have a variety of capabilities around advanced data protection. So one of the things we'll actually talk about today is, database encryption. So say, for example, I'm running a NetApp filer and I want to encrypt the, the storage that underpins that filer. Vault has the capability to act as a device that can sort of store those keys. Also, say, for example, you wanted to encrypt a Mongo database or something like that. We have the capability to do that. So you can think of Vault sort of as a Swiss Army knife of, dealing with secret data. I threw this slide in here because I thought, since we're talking about secrets management and secret data, I should probably define sort of the scope or the terminology of what we're talking about. So secrets can be anything. It could be the usernames and password combinations. It can be, API keys to access your cloud environment. It can be certificates that you use to encrypt, or maybe to verify identity. And the list goes on. So secrets are typically things you don't want to be public. This could be tokens for CI/CD pipelines or something like that. However, we also sort of define secrets as, sensitive data. So Vault has another capability under the sort of advanced data protection umbrella, where we call it the transform secret engine, and this allows you to do things like tokenization and transformations on data. So, say for example, I'm a large hotel chain or something like that. People are checking in. Maybe I'm hanging on to their credit card numbers. Maybe I have flight details, passport numbers. There's a whole variety of sort of PII data that a bunch of companies are collecting, and they need a way to actually secure that data when it sits in a database. So, when we sort of talk about secrets management, we sort of cover both those sort of use cases, secrets and sensitive data. For the secrets management specifically, we try to think about the workflows sort of at a high level. And, when we were designing Vault, these are a lot of the sort of use cases that we're trying to touch on. So, how do your applications actually get secrets? So say I'm an application and I want to access a database. Well, I'm going to need a username and a password to access that database. How do you actually do that? Or maybe I'm a human and I need to, acquire a secret to log into some sort of environment. Where am I getting that secret from? Sort of what's the life cycle of that secret? Particularly with Vault, we look at sort of machine to machine secrets. So, hey, I'm a database. I have a username and password that I can access it. How is that secret updated? How is it revoked? How are these secrets used? So you want to do some analytics, probably logging and monitoring. And, say there's some sort of a compromise in your environment. How do you deal with that and remediate it? So there's sort of two core guiding principles that we focus on when we're chatting about Vault. These are the last couple of slides about Vault, and then we'll dive into the content. So, one of the main guiding principles is that we want to be, API driven, that we want to integrate with your environment, the way that you expect to integrate with us. So, we want to automate, control, and secure the infrastructure through an API. So any of the capabilities within Vault, you can do it through the API. And we also want to have, a rich set of integrations so that if you have a particular tool that you're using, you can actually integrate it with Vault. And I think we just rolled over the number of 100 integrations. So these are popular sort of integrations. So say, for example, hey, I'm using AWS, Azure, or GCP, and I want to interact somehow with maybe their IAM functions of, generating a dynamic credential to access the environment there. Or, hey, maybe I want to rotate a password on a MySQL database or something like that. So there's a variety of different functionality. Chances are if you have some workflow where you're dealing with secret data, we probably have a plugin for it. And the final slide I have on sort of the, Vault 101 is there's sort of 3 different ways you can actually run Vault. So Vault is an open source project that, really is driving the sort of pace of innovation in the feature set. This is by far the most popular way of running Vault. There's millions of downloads around Vault. And then the next sort of step up is Vault Enterprise. This is where you could sort of think of it as a layer on top of Vault open source. This adds, enterprise features. So say, for example, earlier I talked about, hey, I'm a hotel chain. I'm dealing with secret data. Obviously, you want to make sure that solution is highly available and, will be up in the event of a disaster. So the enterprise version of Vault adds those types of features. So, you can run Vault in a highly available cluster. And it's up all the time, as well as if, hey, there's any issues, you can call us for support. Typically that's, customer managed. It's maybe in their data centers or in the cloud. And then the sort of third option of how you can run Vault is through our cloud platform. So this is a managed version of Vault. So, maybe you're an enterprise, but you don't have the in-house expertise to actually run Vault and maintain it. We'll do it for you. So, there's a wide sort of spectrum of how you can do it, but if you're interested in any of that stuff, there's the links. All right, so that's it for sort of my Vault 101. If you have any questions, definitely pop them into the Q&A and I'll answer them. So let's dive into what's new with Vault 1.9. So this release, we tried to focus on, the broad integrations of, making the integrations that we already have, sort of more refined and sand off any of the rough edges, as well as extend the capability. Particularly in this release, we looked at a lot of feedback from the community as well as enterprise customers, and rolled a lot of that into the product. So, try to make it more reliable and easier to use, as well as we made some improvements around advanced data protection. So one of the things we'll chat about in a minute here is, if I'm running a Microsoft SQL Server and I want to do, transparent disk encryption, that use case sort of falls into the advanced data protection feature set. So on the ecosystem side, there's some pretty cool advancements here. So we'll chat about OIDC in a little bit more. I have a slide dedicated to it, but sort of the highlight here is that Vault can now act as an OIDC provider. So what this means is, say, I'm sure we've all gone through this workflow of, hey, I wanted to sign into a third-party website, and I get redirected to some sort of a third-party auth provider. So, maybe I want to log into a particular product. It says, hey, do you want to use single sign-on? Bumps you over to Google. You log in, then it bumps you back to the app. So that's sort of the OIDC workflow. We've had the capability within Vault for a long time to act as, OIDC client, but we added the capability now to act as a provider. So that's pretty cool. We've updated the key value secret engine to allow patch operations. So what this means is you can patch, secrets without actually having the capability of reading them. So I have a dedicated slide for this too, and we'll sort of work through what the workflow looks like, but we've sort of scoped down the permissions that you need when you're interacting with secrets, so that if you have a use case where, hey, I only want to update the metadata around a particular secret, you can do that without actually reading its contents. Another feature that came in through a customer was they needed the ability to add custom HTTP headers. So earlier when I was chatting about, hey, Vault is a central service that sits on your network and is sort of a secrets management Swiss Army knife. Typically how folks interact with it is through the API. So that means you have, an HTTP server listening on your network. And particularly in large enterprise organizations, what they'll do is they'll scan the entire network and look for sort of any vulnerabilities within that infrastructure. This particular request came in of, hey, we need to add these custom headers to Vault so that our security scanning tool will say that Vault complies with it. So maybe you have a specific caching header or something in there that you need to comply with. So that's particularly what that targets. We'll look at that in a little bit more detail in a second. We've updated the Vault Terraform provider. So this update primarily looks at updating to SDK version 2 to sort of take advantage of the new features there. We've also updated the Go client library to support the login function. So before you might have been rolling your own sort of login support, but now we have a supported version that works across a variety of different auth methods. So if you're using the Go SDK, definitely check that out. And then, when you're interacting with Vault, you can either go through the CLI, the API, or we actually have a web UI too. So we made a variety of updates to the web UI around supporting database secrets engines. So we added Oracle, Elasticsearch, and Postgres, as well as we updated the interface around PKI. So the use case here is, say I want Vault to act as a certificate authority. Maybe I'm generating internal certificates to, for some sort of a device to maybe, authorize it or, verify its identity or something like that. So when you actually go into Vault, if you're interacting with it through the API or the CLI, you can look at the metadata associated with that particular certificate. But on the web interface, we didn't have parity with, say, hey, I want to look at, the expiration date or the serial number or something like that. So we've updated the interface to add that. Again, that was, through a customer request saying, hey, we need this capability. So a lot of the open source features or the ecosystem features that you'll see in the changelog are primarily driven, through customer requests. So I sort of wanted to deep dive on the OIDC provider for a second. So as I mentioned before, Vault had the ability to act as a OIDC client for a long time. So the use case here is, you fire up Vault, then you need some way to, authenticate against Vault so you can log in and do stuff. And so we had the capability to connect Vault with a variety of third-party providers. So say, for example, I want to log in with Okta or something like that. You'll configure Vault to interact with Okta like that. And then, you can, log into a Vault using your Okta credentials for single sign-on. So we've flipped this around. Now, Vault can act as both a client and a provider. So say, for example, you connect Vault to your internal LDAP directory. You can now create a Vault OIDC provider that can act as a provider that sits on top of your auth methods that you have enabled. So you can actually hit that directory and then authenticate users off that. So it's a pretty cool functionality, and it definitely extends the use cases. We're pretty interested in what folks will use this for. Right now, it's in technical preview. So things might shift a little bit as we gather more feedback. This is sort of our, beta phase, I guess you'd say, with the technical preview. So if you have any feedback, definitely let us know. I should also mention that, I'll publish the slides so you can actually get all these links. But if you go to the blog, it'll definitely have all the links in there to the documentation and Learn Guide. So if you want to actually get hands-on and do this, you can follow Learn Guide, and it has, step-by-step instructions on how to use it. So another feature that I wanted to deep dive on for a second is around the key value secrets engine patch operation. So this actually came in through a customer of, they're saying, hey, you know what, we want to update the secret of a particular a secret of a secret. So they want to actually update, say an API key within a secret. However, they didn't want this particular application to have the ability to go in and read the secrets that it was updating. So, if there was say there was a compromise or something, they don't want someone to get in with that credential and then go and be able to read the secrets. So they want to just generate a new secret and update it. So we've added this new patch functionality, which gives you that ability. So, hey, I want to update this secret. You can just generate a new version, and you don't have the capability to actually read the contents. So it's pretty cool. And hopefully it unblocks that customer. The second or the third one that I wanted to sort of double click on here is around the custom headers. This is, so in the sort of highlighted block here, I've demonstrated what it would look like to add to, custom headers. Maybe I want to add strict transport security, or maybe some sort of custom header. You can also do this on by the response code. So, in here I have response code 200, but, maybe I wanted to do it on a, 504 or 300 X error or something like that, right? So you have the options or the flexibility to define it however you want. Looks like we have a question here, so let me just pop this open. Jack asks, how is this different than the existing patch command? I think it's just that it's scoped down to, only allow that particular permission. So of, only writing the credential and not reading it. But let me just, I'll pop the links in the chat here for all the documentation, and you can That way you get it right from the source. So if you're on the chat, I'll just pop the blog, the learn contents. So Jack, if you go to the blog there, you can just find the documentation for that patch operation, and it explains it in detail. But yeah, it's just to scope down the permissions of, so you don't have the ability to read the contents. Perfect. So now I'll jump over to the enterprise features. So as I mentioned before, there's sort of three ways you can run Vault. One is the open source, one is enterprise that has, additional capabilities around, high availability and disaster recovery. And the third option is managed service. So for Vault Enterprise, we updated the key management secret engine to support GCP. Key management secret engine is basically, maybe I'll back up for a second. So say I'm using a cloud provider. The cloud providers, all support, encryption of data at rest. So say, for example, I'm using Google, I upload something to a particular bucket, or maybe I'm using BigQuery or something like that. I have a large data set in there. At the block level, they're actually encrypting that file system, right? So, if someone were to break into the data center and wheel out some of those servers, they're not going to have access to the, file contents unless they have the encryption keys. However, a lot of large enterprises want to bring their own encryption keys. And so that's what the key management secret engine allows you to do. It allows you to manage the lifecycle of those keys. So you can imagine, hey, I'm a large enterprise. I'm using a few different cloud providers, and I have 50 keys that I'm using to encrypt my data. That lifecycle becomes, pretty complex, and you can use Vault to manage it for you. Vault also has a capability through the Transform secret engine of using tokenization as well as format preserving encryption to protect sensitive data. This is things like credit card numbers, social security numbers, any sort of PII data. I have a couple slides in here where we'll sort of deep dive on it, but this particular feature is around, sort of the input that you pass to Vault and, the parsing of it and stuff like that, so that, we can sort of have some flexibility in the, input and output that you're getting from Vault. It's a little bit sort of abstract, but once I show you the diagrams in the following section, it'll make sense. We also added the capability for transparent disk encryption on a Microsoft SQL Server. So again, where I was sort of chatting about, hey, I want to encrypt data at rest. This is particularly targeted at that use case. So I have a MySQL server. I have a few tables that, I want, or a few databases where I want to encrypt the actual contents. This is the data files as well as the log files. You can use Vault as a third-party provider to, manage the keys that support that workflow. The final sort of enterprise feature that I wanted to chat about here is around namespace API locking. So, Vault is a centralized service where, it holds a bunch of secret data. So what happens if all of a sudden you notice something weird going on? Maybe maybe you notice some weird log traffic, or, hey, this particular key is getting a lot of traffic, something's going on. There's a few different break glass sort of scenarios. Sort of the large one is, hey, I'm just going to seal Vault. So what that does is basically you're locking Vault and you're saying, hey, I'm not going to allow any traffic. However, if you're a large customer or, a large open source user, that's obviously problematic because you likely have a lot of applications interacting with Vault in real time. And, just shutting down Vault is obviously not a good solution. So we've added the capability to lock a particular namespace. So namespaces allow you to sort of segment different applications into their sort of own carved off area. And so using the namespace API locking, you can, let's sort of go back to the same scenario. Hey, I noticed something weird happening on Vault, maybe a particular key, or it might even be, an internal application is misbehaving and all of a sudden it's generating thousands of requests per second for a particular key. That's obviously sort of an anomaly. So maybe rather than having a break glass scenario where I've shut down Vault entirely, now I can just shut down a particular namespace. This also has the added benefit of, you're not turning off logging or monitoring. You can actually go in there and sort of inspect. These are capabilities that you wouldn't have if Vault is locked or sealed. Looks like there's another question here, so I'll just dive in. So the question is around, hey, I have an OIDC provider and I want to use sort of an external directory to, authenticate users. So that's exactly the use case that this supports. So, you can connect your external directories to Vault, and then you can have Vault sort of act as a bridge between those directories. So yeah, it's a amazing functionality, and I think it's going to open up a ton of different use cases. So definitely, in chat there, I posted the link to the blog as well as the Learn Guide. So we have very detailed documentation on the website that sort of walks through the use case, as well as a hands-on lab. If you actually want to go and implement this today, you can set up a development environment and go at it. I think after the presentation here, I just have a few more slides. I'll just sort of walk over what the hands-on labs look like, so if you want to get started. Great. Cool. So let's deep dive on the key management secret engine piece for a second. So I sort of mentioned before, hey, if you're interacting with a cloud provider right now and you're bringing your own encryption keys, it can be quite cumbersome to sort of manage the lifecycle of those keys. So maybe I'm using a particular key to encrypt a bunch of data. However, you're probably bound by some sort of regulatory requirements to sort of rotate those keys or manage the life cycle of those keys. So how do you actually do that? You might have some sort of Excel spreadsheet that has 50 keys in there, and you're sort of looking at the dates and, oh, hey, is this one revoked? Is this one current? You're sort of becoming the lifecycle management tool versus passing that off to a tool like Vault. So that's very much the problem that Vault is targeted at. We're looking at around automating the lifecycle operations, like creating keys, reading keys, updating them, rotating them. So Vault 1.9 adds support, GA support. So it's, if your enterprise customer will support you in this use case against GCP. So right now we have support across the board for AWS, Azure, and GCP. So if you have you're interacting with any of those KMSs, we'll support them. So earlier I sort of talked about advanced IO handling for Transform FPE. So let me sort of walk through what the workflow looks like. Sorry, I just see a question in here. So looks like someone's raising their hand. If you have a question, definitely just pop it into the QA section and I'll answer it. So around the Transform secret engine, earlier we talked about, hey, Vault supports sort of two use cases around secret data. One is, we think of secret data like API keys, tokens, all that sort of stuff. We also handle sensitive data. So say, for example, I need to encrypt or decrypt, a credit card number. Or, maybe I have a large database or data lake that has a bunch of PII data, say your large hotel chain or something like that. You have passport numbers, flight numbers, a whole bunch of details about, folks' travel history. You obviously don't want that sitting in a database, unencrypted. So this is primarily the use case Transform is targeted at. Of, up top here, we have a credit card number. You can pass it to the Transform secret engine. You'll get back something that looks like a credit card number, but it's actually encrypted using format preserving encryption. Why this is cool is, say I have a large database, it has billions of rows in it or something like that. You don't actually need to go into the database and change the schema. You can just use the Transform secret engine. We'll encrypt the values. So you can use the same schema. And even if you wanted to do, say, data analytics on this, you can give it to a data scientist. They can actually work with the what looks like real data, even though it's encrypted. So there's sort of a bunch of use cases in there that are pretty cool when you're using, format preserving encryption. We also support tokenization. So say, for example, I want to use a credit card number, and I absolutely don't want any way that I can reverse this credit card number. You can use a token, and that can sort of stand in for what a credit card number looks like. So what is this advanced IO handling? So the way Transform works under the hood is you can sort of set up these templates that will, use regular expressions that are looking for data. This might be a little hard to parse, but I'll sort of walk through it. So up in the top here, we have this pattern. So, hey, I have a pattern. It's looking for a social security number. They're typically in the format of, 3 digits, 2 digits, and then 4 digits. And then I can sort of specify, hey, what's the encoding format and what I want the output formats to look like. So, in the encode section here, I might have just, a normal social security number. That's, typically 3 digits, 2 digits, and 4 digits. However, maybe in my data set, I have, data that's prefixed with a social security number, or maybe it's lowercase and there's no spaces. And then these are sort of the output formats. Sorry, I was just sneezing there. Great. So essentially what advanced IO handling does is it allows you to support a variety of different sort of input and outputs. If you're using this, you can check out the documentation. It just basically gives you a lot more flexibility in what you're doing. The reason why this is, I think, pretty useful is that, you don't need to transform the data before you give it to Vault. You can actually say, hey, Vault, look for these particular patterns, as well as, the output that comes out of Vault. You don't have to have some sort of post-processing step or something there where you're saying, okay, hey, I got this value from Vault. Now I need to transform it into what my application's expecting. So you can do sort of that pre and post processing right in Vault that covers, the formats that you're expecting. Great. So the second to last slide here is around transparent data encryption. So we sort of chatted about, hey, Vault has these advanced capabilities around, encrypting data. So particularly for Microsoft SQL Server, has the ability to encrypt, log files as well as the database tables. So the sort of value add or the problem that we're seeing people have is that, they're enabling transparent disk encryption, but how are you actually managing those keys? So say, for example, there's some sort of catastrophic event on the SQL Server. What happens to those keys? If you can't get the keys back, your data is unreadable, right? So you need a way of managing the lifecycle of those keys. So you can actually use Vault as a sort of external provider that will protect the keys in the event that there's some sort of issue, as well as it helps you manage the lifecycle of those keys. So imagine, obviously a lot of large companies, they don't just have one Microsoft SQL Server, they might have hundreds or thousands. So Vault can act as sort of a central resource for managing the lifecycle of those various keys, which is pretty cool. Sort of when we talked about, using the key management secret engine to, manage the keys that you might upload to a cloud provider. Same thing goes for this use case. If I have 1,000 SQL servers, how am I actually managing those keys? I might have an Excel spreadsheet somewhere that has all the keys in it, and I'm going through and trying to figure out, hey, am I in compliance with what I'm trying to do here or not? Whereas with Vault, we're offloading that sort of workflow to a tool, which is obviously pretty useful. The final slide here is, I think we already covered this around sort of the break glass scenarios with Vault. Before we had only one where it was, hey, I'm going to, lock Vault or seal it. Now we've added this additional capability to lock or unlock a particular namespace. This gives you much sort of tighter scope and, sort of, if you notice an anomaly, hey, I want to lock down the particular area. I don't want to lock the whole thing is essentially what you're looking at here. All right. So again, I've posted the links to all the documentation and hands-on learns guides in the chat here. So maybe I'll just open those up and we'll just briefly chat about them because I think they're sort of invaluable resources. So I'm just going to get out of the presentation here. So again, there's a very detailed blog. It walks through all the features that I just walked through, as well as giving you documentation. So, hey, I'm interested in learning about the key management secret engine for Google, or hey, I'm interested in learning about the patch operations or transparent disk encryption. You have all the docs right there. However, there's also sort of an invaluable resource on our Learn site. So if you haven't been exposed to the Learn site, it's basically sort of a gold mine of hands-on labs. So, with each release, our amazing Learn team puts together a whole slew of different Learn guides. So say, for example, I think there was the question about OIDC provider, right? So, I'm going to go in here, I'm going to look at, okay, hey, I can set up Vault as an OIDC provider. It'll say, hey, this features in technical preview, you need Vault 1.9. And then it sort of walks you through step by step of, okay, how do you actually configure this? How do I get it going? What are the expected results and all that kind of stuff? So it's just amazing. Particularly when I'm learning a new tool, I want to get hands-on with it, right? So this is a great companion when you have Vault open and running, and you can just sort of run through the hands-on labs. All right, so that's it for the presentation. What I'm going to do is I'll just jump over to chat here, and if there's any questions, definitely pop them in there and I'll answer them. I'm just going to mute myself for a second here while I read through. So there's a question in here about sort of around, I think it's, so if I'm using, the key value store to save a secret. So say, for example, hey, I have, an AWS API key and, an access token. Those typically are, you could store them in a key value store. So you could say, hey, I'm going to use Console to store it, or I'm going to use Redis. What's the benefit of using something like Vault over just a normal key value store? The sort of main thing that I would sort of say is, let's step back from this for a second. Vault, obviously can use you can use it as a key value store to, put secret data in there. However, sitting sort of on top of that or underneath it, however you want to think, is we have, auditing and logging capabilities. So, we can look at, hey, when did this particular person look at this particular key, as well as monitoring. So how many times was this particular key looked at, as well as sort of policy that sits on top of it. Hey, when a person authenticates with Vault, they have the ability to look at these particular keys or only update them or delete them or something like that. So it's more of sort of the umbrella of features that sit around the key value store that sort of make it important. Obviously, Vault encrypts data in transit as well as REST. So there's a variety of sort of companion features that sit alongside that key value store. Obviously, key value is just one sort of workflow or capability within Vault. There's obviously, as we chatted about, 100 sort of different integrations that you can make with Vault. So hopefully that sort of answers the question there. If anyone has any other questions, I'm happy to answer them. There's a question here about, hey, I have a customer. I want them to use the key value store in their application without actually being able to see the key value in plain text. I'm not sure I really understand the question. So you want them to access a key, but you don't want them to see the contents? I imagine there's probably some special use case around that. Looks like, yeah, for that one, I don't have enough sort of, I guess, context around the question to probably answer it. Looks like there's another question here. Sorry for the sort of lag. I'm just reading the questions and then I'll repeat them and then sort of give my answer here. Yeah, so the question here revolves around, maybe I'll back up a second, sort of frame the question. So Vault, obviously is a centralized store for interacting with secret data. However, when you actually put something in a Vault, where does it physically live? Is it sitting on a disk somewhere? Is it backed by a cluster that's some sort of a storage engine or something like that? So there's a few different ways this can work. Obviously you want Vault to be highly available. So we have a few different recommended options. One is to run a Consul cluster where you actually use Consul as the data store. However, our default recommended solution is to use something called integrated storage. This is where you can run a 3-node or 3-node plus sort of cluster that runs in a highly available manner. So if, hey, one node goes down, the other ones will take over for it while you're sort of fixing that issue. And the question here is, hey, what's the recommended cluster size? Sort of the default recommended cluster size is 3. So, that's a highly available cluster. If one node goes down, you have 2 other nodes that can take over. That is sort of our default answer. The question here is, hey, is this production ready? What about performance? So for a 3-node cluster that is totally production ready, we recommend that. However, it's highly dependent on how many requests per second or what's the sort of performance requirements that you're looking for. So, if you're hammering the cluster and you're expecting, 50,000 requests a second, obviously you need to sort of benchmark it. I can't give you sort of the answer of saying what's the recommended cluster size. I'd start at 3 and then sort of benchmark against your application to figure out, sort of what's the round trip time of the request and stuff like that. I know it's a sort of a complex answer and sort of maybe a roundabout way of giving it to you, but I'd say start at 3, benchmark your application, and then add nodes until you get the expected, performance that you're looking for. With Vault Enterprise, we have something called read replicas that sort of act as a cache for various auth methods. So that might be an option too. I'm not sure what version you're running there. So the next question here is, so can FPE transformations call arbitrary functions? So we don't have sort of an external trigger or something like that. So I think the question here is, hey, I want to, transform or tokenize, credit card numbers. So I pass it to Vault. Vault gives you back, the encrypted or tokenized value. I think the question is, hey, can we trigger some sort of external function? Right now, it's 100% driven by regular expressions. So when we're looking at the data, we can't sort of call out some external, function to parse that data. However, that's sort of an interesting use case. We have a discussion forum. Also on the blog, you can submit, feedback and stuff like that. So if you have a real need for that, I definitely sort of reach out to us and, maybe we can look at chatting with product management about it. Great. Thanks for the question. I think we'll just answer a couple more here. Obviously, this is being recorded. You can access the slides and the recording after. So let's go on to the next question here. Yeah, so there's a question about, hey, I want to integrate with ServiceNow. Yep, we support ServiceNow. So I just Google HashiCorp Vault ServiceNow, and you'll find the page that talks about the integration. So you should be good to go there. One of the questions here is, hey, I'm running a Kubernetes cluster or multiple Kubernetes cluster, and I want to use Vault sort of as a external way to inject secrets. So the recommended way of doing that is, we have a Helm chart, which allows you to set up, a sidecar proxy. So there's sort of two ways you can do this. One is you can have Vault actually run on your Kubernetes cluster, and then run the sidecar injector, the injector agent right on there. How it works is, we intercept sort of the calls for, I forget the exact terminology, but basically we're hooking into Kubernetes so that, hey, when you're fetching this particular annotation, we can inject the secrets into your Kubernetes pod so that, hey, it can redirect to Vault. This is all based on the, Vault agent injector tool. So the question here is, hey, I want to inject secrets into my Kubernetes cluster or multiple clusters. Do I have to actually run Vault, alongside my workloads, or can I access it via an external cluster? So we support both use cases. One is, hey, you can run Vault actually on your Kubernetes cluster. Also in that Helm chart, there's something called like, an external Vault path. So you basically put, your Vault cluster URL and all your details in there, and you can, inject secrets from an external cluster. So yeah, we support both use cases. Also, if you just go to our docs, there's both those sort of workflows are well defined. So you can go in there and look at how to do both, as well as we have a learn guide on that talks about that stuff. So hopefully that gets you pointed in the right direction. I think the final question we'll close out with here is, hey, I want to store some key value pairs. Should I be using Vault or Consul? I think it really depends on your use case. If the key value pairs aren't secret metadata and you already have a Consul cluster installed, or maybe you want to use Redis or something. I think it depends on, sort of the security that you want associated with those key value pairs. My sort of default answer is, use the tools that you already have. If you have Consul already and you don't need, these aren't PII or secret data that you want to store, then I'd definitely just use the tool you already have. You don't need to add another tool. Or if you're already using Redis or something like that, just do that. However, if you want the sort of added benefit of, logging, monitoring, and it's actually secret, data, obviously you want to, encrypt it in transit and at rest and all that stuff. So Vault might be the answer to that question. I'm not sure. It depends on the data. All right. I just wanted to thank everyone for, joining the webinar today. Hopefully you found it useful. If you're interested in playing around with any of this stuff, definitely check out, the hands-on labs, as well as the blog has all the info. All right. Thanks very much. I'm going to pass it over to Kaylee.
Awesome. Thanks, Justin. Thanks for the presentation, and thanks to everyone who submitted questions. I hope everyone enjoyed today's live stream and is excited for Vault 1.9. As I mentioned earlier, we're going to make the recording available within probably 1 to 2 business days, and we'll send an email to everyone who registered with the link. And that will conclude our call today. I hope everyone has a great day.